Hi there. Hope you're doing well and enjoying the summer. Welcome to another episode of Anirvan in Conversation with Industry Experts. One of the most defining technologies that we're looking at in the 2020s is definitely artificial intelligence. But how intelligent is artificial intelligence really? That's the topic of discussion for today. And we're going to be joined by Jasper, who is the CEO of Brain Creators and an industry expert in artificial intelligence. Welcome, Jasper. It's good to have you on our show today. Let's start with a brief introduction.
I'm Jasper. I founded a company called Brain Creators with my former classmates from the University of Amsterdam, where we all studied artificial intelligence back in the 90s. And our mission is to make accessible software to do automation through AI without needing all the technical knowledge.
Excellent. The topic that we chose for today is how intelligent is artificial intelligence? What's your perspective on that?
That depends on what you actually mean by intelligence. So we use a formal definition of intelligence, which actually means learning, and it's the ability to gather and apply skills and knowledge, which basically means you can learn new things. So that definition brings artificial intelligence to a form of learning which is artificial, so done by a machine. So anything that learns on its own, by itself, that gains new knowledge and gains new skills and can apply it, is artificially intelligent. And now a mistake lots of people make, also in marketing, of companies and big companies even, is comparing it to human intelligence. Just the ability to learn doesn't mean it's humanly intelligent, and it has feelings and it has creativity and emotions and a large context to switch through. So that's where it becomes difficult. So if you ask me, is it as intelligent as humans? No, it's certainly not. Is it intelligent? Yes, it can learn on its own. So in that sense, it is intelligent.
Right. Now, we have seen artificial intelligence being used in wide array of activities across different industries, across different functions. And as you and I we've spoken about earlier, is that the level of intelligence that's being used in those applications vary quite a lot. What's your opinion on the way the artificial intelligence is being used?
That's also a very broad question, because artificial intelligence is never used to the strict definition of, is this a self-learning artificial system? It's a fashion term, and it has been for the past 8 years, meaning that people stick it onto everything because it sells. So what used to be statistics is now called artificial intelligence. So the weather is quite hot today and it's beautiful. So I can predict, if I take the ice cream sales of the ice cream company down the street, that they are going to sell a lot of ice cream today. That's a statistical rule I can create. Well, if I automate that statistical rule and I say, well, look at the weather prediction every day and predict your ice cream sales based on what you did the last 5 years when it was a nice day, you have a system that predicts ice cream sales. We wouldn't call that intelligent. That's like a statistical rule. But nowadays, all that stuff is called artificial intelligence. And this is okay, right? This changed over the course of decades. And since the 1950s, we have been working on artificial intelligence, and it has been different things, from robotics to in-car navigation to you name it. And as soon as humanity starts to understand how it actually works, we usually stop calling it artificial intelligence. So a simple robot arm, we don't think is really intelligent. It's just programmed to make certain movements at a certain time. In-car navigation, we understand how you navigate a map, and that if there's a congestion somewhere, that you find an alternative way to get to your end location, and you can predict how long it's going to take based on previous attempts or other cars in the same area. So we stop calling it intelligent. And today, we call everything AI again, because we're on the new wave of the hype. But we'll stop calling most of the stuff we see today intelligence. Self-driving cars, the peak of artificial intelligence, they're basically object avoiding machines. So they learn how to avoid specific situations and specific objects and recognize what's around them and predict what's going to happen in front of them. once we understand how this works, that is not intelligent anymore. And then maybe the next wave of AI hype, we'll see a more intelligent system that's maybe a crossover between human tissue, brain tissue, and electronics, and that has new features that maybe are more human-like, and that will be the next wave. So what's being applied in the field today is called AI, and it's all sorts of automation. It's from desktop automation, robotic RPA, as they call it. That's only called AI because it has the word robot in it, but it's basically a rule set defined by observing human behavior and then executing those rules. Is it AI? Well, in our definition of is it self-learning? No. Is it automation? Yes. So if you stick AI onto everything that's automation, you could call it AI. Then again, you could call any IT system that automatically does something AI. And that's actually what we see happening a lot today, that any form of automation is automatically associated with AI by humans. And then at the same time, when you hear humans talk about it, they all say it's disappointing because it's not general AI, it's not broad AI, it's not human intelligence. No, of course not. It's the automation of tasks, and in our definition of a learning system, it's where a system has learned to perform a certain task, learn knowledge, learn skill, and do something. And in reality, it's the point where AI is at now is exactly that, automating smaller tasks. And if you automate a whole bunch of small tasks, you end up with a quite complex system of automation, which is AI. But the more pessimistic people quickly say, well, that's narrow AI, we can only do so much. And that's true. But still, it's very useful, and you can't ignore it because it is going to change much of our lives, and it is already very rapidly.
Right. So the way you explained it, you brought about two terms or two sort of concepts. One is automation, the other one is the statistics, which I think is a very interesting spin. Now, to your point about automation, you're absolutely right. When it started out with computers, it was again the automation, and human beings have been exposed to getting their things done better, faster, more efficient since the Industrial Revolution, right? They're kind of riding the same wave even when it comes to artificial intelligence. The bigger question is now with statistics being thrown in, it is more of the same, much faster, more efficient, and better. Do we really need that intelligence of the artificial intelligence, the self-learning? And if yes, what would be those scenarios?
Yes, because we do execute still, even though we've had the Industrial Revolution and maybe 3 of them by now, we do still have a lot of tasks that are performed by humans or by systems created by humans that aren't optimal, in the sense that we just see a lot of people working in Excel still, or visually inspecting objects or materials, which is not really a job where a human is particularly good at, right? We have a pretty short attention span, and we need to eat, to sleep. We're easily distracted, etc. So we're not very consistent and accurate in performing these kinds of repetitive tasks. And this is exactly where AI comes in, or machine learning comes in teaching a computer to perform tasks that require a certain amount of knowledge, because you have to know what you're doing, you have to be educated to execute the task, but it's not very creative, it's very repetitive. You don't have to think like, okay, so maybe if we chop down a tree and we burn it, we can create a fire that will cook our food. That's human reasoning that a machine is not going to come up with currently. But assessing which tree to chop down by looking at its state and saying, okay, this tree is about to die anyway, so these can be chopped down. That's a task we can easily automate, and we don't have to do it anymore. We just have to have a system in place that chops down trees, and that is how it's going to help us. And if you look in factories or in airports or infrastructure, like on road management, there are people looking at coverage of roads for hours and hours and hours, looking for holes and scratches and whatever. And there are people in the factory at Tata Steel looking at a steel plate surface, just assessing whether there are dents or scratches on it, and creating repair tickets. All that kind of work is going to be automated to a large extent, leaving the work of the interesting cases where something really is wrong or something new is happening to the expert, the human expert that was doing all this boring job, while his capabilities are much more in being creative about a new situation. So machines are going to automate all these tasks for us. So it's not a revolution in the sense that there is this new super intelligence that's going to do new stuff for humanity. No, it's the next step in automation. It's where IT stopped because things got too complex. And by complex, I mean in the real world, there are so many rules to create that at a certain point, you can't just write every rule in code anymore. So it makes sense to make a machine write its own code by learning. And that's what machine learning is. So all these tasks, like driving a car, something that is sort of automatic and it keeps repeating itself, we can use machine learning to take over that role to a large extent, right? Even in a car, and we see that with Tesla now, there are situations where the human needs to be alerted because the car doesn't know what to do. And it's the same for this steel factory. Every now and then something will happen, something will have changed in the chemical mixture that was used to create the steel, and it looks different, and a human expert needs to look at it and then tell the machine again, like, okay, I know what this is now, next time you can recognize it, right? To downplay it a bit, the AI is still not magic. It's the next step in automation, but it is a revolution in the sense that it's going to change work. Because out of the 40 hours of work we perform, I dare to say that 30 hours is repetitive work that we do every day, whether it's checking our email or planning meetings or looking at some object. And the part where we really excel as humans is only a small portion of our week.
One of the things that we've observed is whenever it comes to new technology or new process or something new, which is more transformational in nature, that when it comes to companies adopting it, they try to take very small steps, very small as in baby steps, to adopt it. And we've seen this happen with RPA, robotics process automation, whether it's in finance, accounting, processes like accounts payable, or whether it's in recruitment. Bigger question is, are organizations getting ready to adopt artificial intelligence in more core functions rather than just staying at the peripheral function?
Yes and no, because it's such a new concept and it's completely different from programming, coding, IT. It's very hard to change, right? So we're used to IT and we figured out that we can use something like Scrum or whatever. We put the term Scrum on, but some process to manage our IT creation and lifecycle. For AI, that's completely different. So what we saw a couple of years ago was companies trying to get their IT departments to do AI. That was very hard or maybe even impossible. Then they tried to get it from the big suppliers like Amazon or Google or whoever and see if they could just buy it. And that was very hard because their problems were their problems. And Google didn't necessarily have a solution for their factory, for their machine, for their materials. So that didn't work. And then there was this movement where companies started hiring their own data scientists, and data scientists became the sexiest job in the universe, and the definitions varied. So a data scientist can be a machine learning expert that's used to train deep learning models and show machines examples and make them learn from it. But the data scientist is also a econometrics student who knows everything about statistics. But companies weren't aware of this, so they just put 10 young people, paid them ridiculous salaries and said, you're now our data science department or advanced analytics department, go make magic. So they said, where's the data? Well, we have this data lake, here's all the data, go make magic. And the big step they're usually skipping is, okay, so what problem are we trying to solve here in the first place, right? It's not about taking a whole bunch of data and looking for a solution. No, it's defining a problem, and if machine learning or data science or AI is a potential solution, then you could create it. But then again, why would every steel producing company or every telco in the world have his own data science team creating a custom solution from scratch using open source tools, right? So the movement I'm seeing now for the past 6 to 9 months is that companies are moving away from that concept of hiring their own group of data scientists, trying to reinvent the wheel. And what we see coming now is a new generation of software which pushes all the complexity to the background and makes a sort of more abstract, more human layer on top of all these existing tools, and providing it as a user interface to normal people and saying to the road inspector, okay, if you have a boring task you're executing every day, you can now teach a machine to take over 80-90% of that task by just showing it what you're doing. And then in the background, all this machine learning and AI is taking place. But just like with coding, you never see the C++ code of your system. You see the user interface. And this is a normal way of how stuff develops into useful software. And this is also what we are doing nowadays. We're creating a user-friendly layer on top of all that AI technology and just saying, these are the steps you should follow to automate this task, and you can do it. And I think that's where it's moving, and it's just going to be a new way of automating things without needing a lot of technical knowledge, but just the knowledge about the job you're executing, the tasks you want to automate. That's what you should know about, and that's what you should transfer to a machine, and then be able to monitor it and put it into to practice. That's another thing in this phase where everyone had their own data science team. The tendency was to experiment a lot, and then whenever an experiment worked, someone would say, okay, so let's use it, and then everyone would say, well, no, it's really an experiment. It's not suitable to be used in practice, because it was only the machine learning part. It wasn't the whole automation. It was training a machine learning model. But to make something useful, you need a whole pipeline of new stuff coming in, data coming in, whether it's images or video or Excel sheets, some processing where stuff is recognized and classified, but then also some sort of action. Whenever something is recognized, it should feed into something else. So it should feed into the maintenance process, or it should feed into the machine software or whatever. And that's where it's going now. So it's not about very precise point solutions, like we have this one solution for this. And it's not about all this AI technology. It's about putting it all together and saying, we're now going to do end-to-end automation. And in the background, it's going to be using machine learning technology. But don't worry, you don't have to be able to code C++ to use it.
That's a very interesting point. In fact, I've seen taking the technical complexity away from the technology adoption by businesses is key to the process of adoption. And as you rightly pointed out, in the past, people were hiring data scientists, asking them to join their workforce. But now we see a lot more platforms coming up which kind of cover the technical complexity and give users, businesses, ability to use the functionalities of those platforms rather than getting involved in the technical aspects. My next question to you would be, given where the artificial intelligence revolution is, what would be a good starting point for companies to start adopting artificial intelligence in a big way?
I think the key there is not looking at the technology, so not looking at your data, not looking at the AI and all the platforms that are out there and buying machines with GPUs, etc., etc. What we find with our customers is they just want a solution to some sort of problem. And if someone calls us, which happens a lot still, saying, hey, you do AI, right? Well, we want to try some AI. My first question is always, what are you trying to solve, right? But currently, I would say 95% of the market is still aimed at people looking for some sort of AI. So you see a lot of AI consultancies saying, hey, we can do all this magic and let's try something. You have data, and then they're missing the point, because it's not about that. It's not about having data. It's about what are you willing to automate. So whenever we talk to a customer, we just ask, where is the work that's not optimal right now? Where is the inefficiency? Where is the repetitive jobs that are done all the time? And then it takes a conversation to figure out where you can add this value. And that's a starting point. So if you want to do something with AI, the goal shouldn't be doing something with AI. It should be, what haven't we been able to solve with IT so far? Or to what problem do we have a very suboptimal solution because it's just complex to automate? And where are humans still doing this work? and then is it worth automating, right? If it's one human doing a task for 10 hours a week, is it worth the trouble of automating that? Well, maybe not. But if you have a team of, say, 50 mechanics out in the field doing the same thing all over again for 20% of their time, it makes sense to find some sort of automation to take care of it. And that's usually the starting point. So don't think of how are we going to experiment with AI? No, which problems, which inefficiencies, which repetitive tasks do we still have going on in the organization, and what could we save if we automate those? And that's where we can say, okay, so now we have clarity about what the goal is of this. Now here's our platform, and you can start to automate all these tasks one by one yourself. And I think that should be the starting point. So, and this takes some education, because people have to be aware of what kind of task can be automated with AI. And usually the smaller the task, the narrower, the better. And in general, the rule is if a human can do it with the human knowledge and like a human eyes, then we can automate the task to a large extent with AI. If it's something that's very complex for a human, then you shouldn't feed it to an AI model, because it's also complex for an AI model. And again, that's not expecting magic, right? People think, oh, this is a scientific problem we've been struggling with for 20 years. Now there's AI, maybe AI can solve it. Though the human hasn't figured it out, then it's probably not intuitive enough to be seen or perceived. Then it's going to be very hard for AI as well. So yeah, look for the repetitive stuff, the people looking at something over and over again, the people assessing the same situation over and over again, looking at security footage or looking at roads or whatever. That's where you should start and just really automate it with the goal of saving money or providing a better service.
Right. So you mentioned about the repetitive tasks and activities. We call something as organizational inertia to change. Typically organizations, just because there's something new happening in the market, they do not necessarily change themselves overnight. What are some of the changes that needs to be brought about in an organization before they can start thinking, hey, let's start actively and in a focused manner look at all the repetitive tasks that could potentially be converted into sort of artificial intelligence based engines or platforms?
I think the first step is management board level awareness of the potential possibilities, but also about the impact on the organization. So if we come into an organization and we say we're going to automate all these human tasks, then the reaction you're going to get is all our jobs are going to be lost, right? And in the early days, like 2013, 14, we actually got that response a lot because people felt threatened by the machine taking over, right? And that's a completely logical reaction. And even in the first industrial revolution, people were afraid that everyone would be out of work because of steam engines. And in reality, that created a lot more work. And that's also going to happen here, because the time you save by not looking at the road 8 hours a day is time you can use to create a road that doesn't break that quickly, or that is cheaper to manufacture, or a process that gets it fixed more easily, or whatever. So these same human experts, you're actually wasting a lot of their time on stuff that can be automated, and this time can be used to optimize the product or the service or whatever. If this concept is clear on the board level, it can boil down into an organization, and people won't see it as something to fear, but something that's actually going to help them perform better. And then I think people talk about AI as human augmentation, and I think that's the main point, right? We have a certain level of performance, but right now it's hindered by the boundaries of what we can achieve in a day. If we take away 4 hours a day of stuff that you don't have to do, you're left with 4 extra hours to perform better, and augmented by a machine taking care of the other stuff. And I think this concept, this understanding is, besides all the technical noise and everyone screaming at you, AI, AI, this is what we should understand as a society and as companies and as boards. That is here to augment our lives and help us and make it easier and save time. And in the long run, as with every automation, we have to think about what is really the impact of the way we work and the way we live. So take this a few steps further, right? This is not going to happen in the next 5 or 10 years, but if this type of automation continues and it gets better and better, we will automate more and more and more. And at a certain point, you may ask the question, do we need to work 40 hours a week? Or can we do it like 20 hours? And then what are we going to do with the rest of our time? And how is this going to translate to society? How are we going to pay people for 20 hours, but still have enough buying power to keep the economy alive? And that's where all the experiments with a basic income and stuff come in. And this doesn't have to happen tomorrow because the adoption rate is quite low. AI isn't that magical. Even with our brain matter system, it still takes a number of weeks to train the machine into doing a certain task. So it's not like a company is going to say, okay, now we have 80% of our work automated within the next year or something. So we have some time to think about this. But I think the paradigm of 40-hour work week is going to be outdated at some point, because we're much better at taking it a bit slower, thinking about stuff, and then coming up with great ideas than just being busy all day. And that's currently what we're doing. And that's not sustainable, I think.
Right. So apart from having sort of digital savvy leadership, which is one of the criteria, and the other thing that you mentioned, which is a culture of experiments, what sort of functional and technical skills must a company develop themselves in order to handle AI-based platforms on one side? And on the other side, as you rightly pointed out, things are evolving so fast. It probably does not make sense to house all of those experts in-house, but rather engage other companies who have specialists who are in that area. So what's your view on those 2 points?
Yeah, well, I like to compare it to, I'm slightly older, I'm in my 40s, so I had the revolution of the internet. I saw it when I started studying in 95. Nobody had a website, and the internet was something completely abstract, right? It was this information superhighway, and you could go on it with hypertext markup language. Recognize the similarity with AI now.
Yeah.
It's all terminology. We went surfing on the information superhighway, that kind of stuff. And in reality, there was nothing. There were black pages with Comic Sans text on it and blinking Christmas lights once a year, if you were lucky. And nobody was on the internet, right? So when that started happening, you needed computer programmers who were capable of doing this hypertext markup language to build a website from scratch and make it work and present it to the world and get it hosted on some sort of Apache server, or I don't know what we had at the time. And then you could go to a browser, which was what we called Netscape and stuff. And it was all coming up. And I see it very large similarity to what's been happening in AI the past years, right? It's completely confusing technological innovations, programming languages, hosting with the actual results, which is a visible page on your computer screen. And I think with AI, the actual result is some sort of automated task. And all the rest is technical noise. And then what started happening in web technology, sorry, is that at a certain point, CMS systems came up. So content management systems. And they sort of put all the technical stuff and all the CSS and HTML and hosting to the background. And they just say, here's a user interface on your screen, and you can just write the text you want to have on your website. And you can upload a picture you want on your website. And then e-commerce started happening. You can also upload products and have payment services, etc., etc. But no CMS confronts a normal user with the HTML language. Maybe a little bit, because programmers also can use it, but in practice, in large companies, the marketing department is updating the website. They're not doing this by coding anything. So I think this same movement is now happening in AI, where nobody at large companies will code actually Python or talk to TensorFlow or whatever. They will just have something on screen saying, this is a road. This is a picture of a hole in the road. Now, here is the hole. Recognize it. And the machine will just take over this task and execute it and show the user on the same screen, okay, this is where I saw holes and this is where I didn't, and this is the action I took. Like Brain Matter does it now. And that's comparable to this CMS. So that's what I see happening. That's not something new. It's a very natural way of evolving from hype terminology to a useful system. And now we're somewhere in between. So at this point, I wouldn't recommend any company to hire a lot of data scientists and start experimenting with technology. I would advise any company to look for examples of what has been automated and look in the organization for tasks that you would like to have automated. Just make a list and then ask a company, ask us, which of these tasks are automatable. I don't know what the word is, but which task can we automate with a platform like Brain Matter, or maybe with a more tabular data focused data platform, or maybe with an open source tool offered by AWS, or I don't know, but take it from there. Just look for what is a task that can be automated using this technology, and don't just take the technology and experiment. Data scientists are technical people. Technical people, per definition, are no business people. So the chance that they're going to pick something to experiment with that actually has a business case is very small. And then if they succeed, there usually is no sponsorship for the solution, because IT will feel threatened because they have a system in place. Procurement will say, well, we spent 10 years on getting this contract with company X and it's a SaaS service, we're not going to replace it. And so that's not going to lead to success. And that's why you see companies saying goodbye to the data science or advanced analytics units. And what's going to come up are exactly these CMS systems that just say, okay, this kind of task, a visual inspection task you want to automate, well, here's Brain Matter, you can do that, right? And this tabular thing you want to automate, well, here's another system from Google that can just do it. And that's how we should prepare and how companies should prepare. So not just hire technical people, think of what you could do to improve and then look for the right solution.
What are some of the challenges that companies are likely to face when they adopt artificial intelligence-based platforms?
There's only one challenge, and that's the quality of their data. And that sounds a bit technical, I admit. What I mean is that machine learning, so I'm just going to focus on the type of AI we do then, machine learning, requires data to learn from. So if I want to teach you how to recognize sticky notes in different colors, I'm going to show you physically, well, this is sticky note, right? But this is also a sticky note. It's just a different color. No. After some examples, you will say, okay, I understand now what a sticky note is and what the color is now. This is a trivial example, but it's exactly the way we teach our Brain Matter system or any machine learning tool a task. Now, if I'm showing you something that's not a perfect sticky note, but it's like half of it, or it's not sticky, or I don't know what, it's different material, you will not accurately learn how to recognize sticky notes. So in practice, this means that if your data is not good, then the machine learning model won't be good because it doesn't know how accurately to recognize something. So in practice, this means, well, sticking to the case of road inspection for a second, because that happens to be a large project we're working on now. If you take movies, video of roads by attaching a camera to a car, and you just feed it all this data, and it's all in bright sunny daylight, and you've seen scratches and things, and then you take it into a production phase, and the car starts driving, and it's raining, and there's reflection, and it has tunnels, and there's darkness, and maybe it drives at night, whatever. Then this data set you used to train it with, which was all in perfect broad daylight, is not the same as what it encounters in reality. So your data set wasn't representative of what you were trying to teach it. And this is something we see a lot in practice, but this is the one factor that determines success for machine learning, is the material, the examples you use to teach it something, is it representative for what it's going to encounter in reality? If that's the case, then it will learn the task. If it's not, it will struggle. But this happens a lot in reality. So, and it has nothing to do with technology. It has everything to do with, did we think about all the situations that we're going to encounter in a live environment, in reality? And did we cover all those cases in our training material? If you did, it's going to work. If you didn't, you need to work on your data set a little bit more. And this, again, is not technical. This is about the road inspector, because only he or she knows what a road looks like and what an error looks like on the road. So they can perfectly create an example set, as long as they're aware that everything is in there that could happen. And then still, you won't cover everything, right? So some strange accident may happen and cause damage in a road that you've never seen before. And that's okay, because a system like Brain Matter will just say, I found an anomaly, a human should look at this and let me know what to do with it, right? So that's not a problem. But the number one success factor is this example set. If you're able to create it and it's consistent and balanced, as we say, so suppose I'm going to teach you sticky notes and I have 1,000 yellow ones and only one blue one, then it's out of balance, because there are 1,000 yellows and one blue. Better is to have 500 blues and 500 yellows. So translating it to road inspection, if you have 1,000 holes but only one scratch, then you need some more scratches to have balance in your data set. And this is what we're trying to teach you. This is the only thing you should have knowledge about if you're automating a task with machine learning, about this very practical thing of what the human knowledge actually is, and capturing that in examples to learn from. Nothing else, because the rest is all under the hood for the system.
Yeah, let's stay on that piece that you just mentioned about, teaching people on what different things they need to do and what they need to instruct the robotics or the artificial intelligence platform. From the way you've illustrated the examples that you shared, I particularly see, and I've seen this in different situations as well with other companies using artificial intelligence, that there is an amount of education, learning, and training that the workforce needs to go through before they're able to teach the machines on different aspects. What's your take? And I believe you have a training course as well on this one, right?
Well, yeah, we have a training course on this awareness, like what kind of task can you automate? And it used to be a separate training course. Now it's just in the onboarding of our platform. So if you buy a license to Brain Matter, you get onboarding, and that's basically the training. And that's not about the technology at all. It's about the type of task to automate, the results to expect, and the way to prepare your data. This can be very technical, because there are all kinds of very technical data labeling, data annotation platforms out there, which are mainly geared towards those data scientists, again, as a tool for them to work with data. Our point is that this creation of examples is not more complicated than just pointing towards what you mean and attaching a label to it saying, this is a hole, right? So just doing that doesn't require a lot of education, but doing it the right way requires some education. So if, for instance, you're Schiphol Airport and you want to detect broken light fixtures in the ceiling, and you have this wide angle picture of everything, then what you should show the machine is where the light fixtures are and what the broken light fixture versus a working light fixture looks like. If you just start to label everything randomly in such a picture and say, oh, this is a check-in desk, and this is the floor, and this is a plant, and this is, by the way, a light fixture, and then you just feed it to the machine, then it's unclear what you were actually trying to achieve in the first place. So you need to be careful about what are you going to show as an example, and what are you going to want as a result. And then we take it a step further and say, once you've done that, you should also define some rules, like a broken light fixture. What should happen? Oh, attach a geolocation, so we know where the broken light fixture is. Attach the moment, when did it break, right? Because we have a stream of images over time. create a follow-up action, and in this case, send a ticket to Maximo, which is IBM's asset management system, for a mechanic to go replace the light fixture. All that is part of the automation, but it will only work if you are conscious of what you were trying to achieve in the first place. You can't just have everything labeled as light fixture. If you want to detect broken lights, then the broken ones should be labeled as broken ones. But like you notice, this has nothing to do with the technical aspects. This is explaining how to teach. And it's kind of similar whether you're teaching a human or a machine in this aspect. Although humans are capable of more than machines. So one of my graduation project in university was about the way kids learn a certain task, a balancing task, with like small pegs on a balance, and they learn in stages. So first it's just trial and error, and then they notice the more weight on one side, the higher the chance of it going down. Then they learn that distances also plays a role, etc. This is different in machine learning. So machine learning is simply showing examples, and if you have enough examples, it will learn. But I can tell you, this is a piece of paper, and if it's square and it's sticky, it's a sticky note. And you will also remember that, and you don't need another 100 examples to remember it. Essentially, that's programming. So I think we will see more and more that machine learning is combined with computer programming, so you can bypass some of the learning by just stating a rule. And then if you combine rules with machine learning, it's much stronger and more human-like again. And that's also why we have a combination of machine learning and a rule engine in brain matter, so you can combine the two. You don't have to do everything with the machine learning model. If you can just straightforwardly say, hey, this is sticky because, then it's much faster. You're taking a shortcut. So we're also looking for this combination. And in the market, I see a lot of focus on, we want to do AI, so it should be pure AI. But no, the goal is automating something, not doing pure AI. So we have a lot to learn as a society here, but I'd rather speak about how you create an example and how you teach and make it similar to human teaching than talk about how this works in a neural network with backpropagation and weights and TensorFlow. That's not needed. We're not talking about hypertext markup language anymore anyway.
Yeah, this is definitely one of the most interesting spaces in the digital world. What, in your opinion, will be some of the trends over the next 5-7 years in this space?
I think, like we see now, there are short-term trends, which is just someone found a way to apply AI and it sort of works, and then we all want the same. So we saw that with chatbots. Chatbots, oh, AI, highly intelligent, blah, blah, blah. It's like having a conversation with a human. Well, I don't know your last encounter with a chatbot, but it's never like that. It's always disappointing. But it's a hype, because potentially we could at some point build a chatbot that actually makes a lot of sense. But up to that point, it's all rule-based, template-based, right? It recognizes a question and it looks up an answer that's kind of suitable. The problem with that is that a really intelligent chatbot that's just like a human needs so much contextual knowledge, because it has to understand and reason about the world, that it's almost impossible to achieve that now, or it is impossible. So then the hype dies. And then another one comes up, right? Recommender systems or predictive maintenance, that kind of stuff. Predictive maintenance is partly machine learning, but mostly statistics again, right? If I know that this machine in general breaks down in 5 years, then I can predict that if a machine is 4 years old, it will break down in a year. Called AI now, not very AI-ish, so also that is sort of over the top of the hype. So all these hypes come and go application-wise. And then there's another layer where subsections of AI go through a hype cycle. And you can see that in the Gartner hype cycle, right? And then suddenly deep learning is on top of the hype cycle. It dies down, and then natural language processing is on top. All this is useful, but that's very technical, right? And I hear business people say, oh, let's throw some deep learning at it, which makes no sense at all. It's like saying, oh, we need a new system. Oh, just use a Docker container, right? That's not how it works. And there is the macro, the big trend, which is how intelligent is AI or deep learning or machine learning as a whole at this moment, and is there a breakthrough? Honestly, there hasn't been a major breakthrough in deep learning or machine learning models themselves since the last century, and not since the 90s, but since the 60s. This is where people like Geoffrey Hinton invented the concept of a neural network, an artificial neural network, and that's still what we're using today. And of course, there have been optimizations and platforms to run it, etc. But there's nothing like a revolutionary new way of doing this that's quickly accelerating the pace where we're going. The only reason we're doing this now, deep learning since 2012, is because computers were fast enough to actually execute it. That's the only reason. So we're on this gradual path of optimization of our machine learning algorithms, by which we mean neural networks in most cases. And that's going to just continue because the whole scientific world is working on it. But it's all steps, right? It's not a big revolution. What could be a big revolution is where you see experiments now with human tissue on top of computer chips. So if we start growing brain tissue on machines, that can be revolutionary, right? It's now at the stage where it's still really done, and but it's starting. So maybe in 20 years or maybe 10, you never know how fast it goes, we will have a human form of intelligence with a body of electronics. And that's where it starts to get interesting again, but also scary, of course, because human organic tissue is much harder to control, right? We're always talking about explainable AI and predictable AI and trustable AI. I think that's sort of a non-discussion because it's perfectly explainable to the level of what's going on in the mathematical level in a neural network. It's just not comprehensible for us humans. For every example we feed it, what comes out exactly, because it's all about math and weights. But with human tissue, we really don't know. So if we figure out how to build a robot with the human brain before we figure out how the human brain works, then we're in dangerous territory. You could have a Trump's brain on a super robot, and that would be dangerous.
That's fascinating. I'm sure some of our listeners and viewers would like to continue this dialogue with you. What's the best way they can connect with you?
They can simply send us an email or chat on LinkedIn. Just connect, and I respond to every message always, unless you're trying to sell me outsourcing or recruitment. But just send an email to jasper@braincreators.com or contact me on LinkedIn.
Sure, we will provide the links in the description box down below. Jasper, it has been wonderful discussion. I learned a lot, and I'm sure our viewers and listeners would have learned as well. So I would like to thank you again. Thanks for joining our session, and hope to see you sometime again in another session in the near future.
Definitely. Thank you for having me.
Thank you. So this was another episode of Anirvan in Conversation with Industry Expert, and today we were joined by Jasper Wagnum, the CEO of Brain Creators, and the topic was artificial intelligence. How intelligent is artificial intelligence? So if you liked this session today, then do not forget to hit the like button, and also don't forget to subscribe to our channel. Till then, I would like to wish you guys all a very happy weekend. Until next time, bye-bye.